All right. So to get started, before I start with the lesson, I like to once again introduce when we start with a new concept. So far, we've done expressions, all kinds of expressions. And yesterday, we finished with a proper introduction to algebraic and numerical expressions. Remember that? And I did it through a concert and so on and so forth. Yeah. So today, we're moving on to equations. Okay. Let me stop really quick. For introduction to equations. You've been with equations for the past, let's say, since third grade. That's what? That's 4. That's about 5 years, right? Okay, so here we go. Now, when you were introduced, they probably showed you the, the equal sign, that this is this, and so on and so forth. So let me introduce it a little bit different. So let's say we were back in the Roman Empire days, right? And back in the days, we're all wearing togas and like long hair and so on and so forth. And when we go to the market, they're going to have these things. These are scales. Who's seen these before, right? You've seen them in movies or in dollar bills or so on and so forth. How these work, there's a bar here in the center holding it, right? And for it to stay in place, they need to have these two balanced. So I go to this guy and this establishment. I'm like, all right, I want to buy 8 pounds of frijoles. So what they do, they start adding weights to this side. And back then, the weights looked, they were like little cylinders, and they were labeled 1 pound, 1 pound, 1 pound. And they weighed 1 pound because they were made out of bronze or some sort of metal. Okay, so if I want a pound of frijoles, they first add the pounds here, the little cylinders, so this side drops. Is that correct? So from there, they place their little sack over here. There it is. And then all of a sudden, they start pouring in the beans. There they are. And they start filling it until when? Until it's equal to that. Is that correct? And all of a sudden, it's going to balance out. That's where they get the main idea of equations. And let me show you with numbers. I started with 0. Oh, sorry. Give me a second. We started with 0 here and 0 here. But then I said I wanted 8 pounds of frijoles, so they added 8 pounds of cylinders right here. Is that correct? So that side dropped. But then what did he do? They added 8 pounds of bean to this side. Is that correct? They added and they added. That's why last year they said whatever you do to one side. Why? Because we need to keep it balanced. So far so good? And guess what? With that same idea, after we're done with equations, we're going to inequalities. Let me show you inequalities. Now, originally that was our scale. Is that correct? There it is. But from there, we're going to move on to here. So now check this out. The original setting of our scale was about right here. Okay? But then it dropped. And let me show you with numbers. Here I have 8. What do I have here? 0. Check this out. 8 is greater than 0. Do you guys see the arrow? Do you guys see it? That's where we get the idea of inequality. In the same way, check this out. If I was to balance this out like this, but in this case, I added, let's say, 23 pounds to this side. Well, guess what? This side is going to drop. Is that correct? What's on this side? 0, which will be the arrow that you use. Do you guys see the arrow? That's when we'll get to inequality. That's a good formal way of introducing equations and inequalities. So in order for something to be an equation, both sides have to stay equal. That's why whatever you do to one side, you do to the other side. Are we there? All right, with that said, our title for today is solving two-step equations. But our objective, I can solve and graph one variable equation. I'm going to generalize it because we're going to look at one-step and two-step equations, okay? So here we go. Our objective for today, I can solve and graph one variable equation. Let's read together. 1, 2, 3. I can solve and graph one variable equation. All right, so we know I gave you guys a note, so here we go. One variable equation. The definition says statements where two expressions are equal to each other and contain one unknown variable. I gave you guys these examples. Is that correct? So now check this out. It says statements where two expressions are equal to each other. So let's see if we remember from yesterday. This expression is known as an algebraic expression. Is that correct? Because it's got a variable, numbers, and operations. What kind of expression is this 25? A numerical, because it only has a number. Is that correct? Are they equal to one another? Yes, that's what the equal sign says, that they are equal. Look at this one. Algebraic expression? Yes. Numerical expression, are they equal to each other? Yes. Look at this one. Algebraic, numerical, are they equal to one another? Yes. These are known as one variable equations because they are equations, and if you notice, each equation only has one type of variable. Are we there? All right, let me show you non-examples. Look at these. Look at each situation. Don't read it. Don't say it out loud. Don't write it yet. Look at this. Why do you think this is not a one variable equation? Why do you think this is not? Why do you think this is not? And actually this is, but the reason I wrote it there because we're not going to be looking at those yet. Look at this one. All right, talk it over with your neighbor. Why are these non-examples? 9 examples. So with that said, we notice that the difference from one to the other, from one variable equations to these, this one's an expression, an equality, this one's a quadratic. We're not going to be looking at till chapter 8, and these are 2 variables. So important thing to remember, they have equal signs and only one unknown variable. They have equal signs and only one unknown variable. Copy that. So for this, we have 4 basic steps. Check this out. And the steps that I gave you are simple. Step 1, simplify each side of the equation. That means starts with grouping symbols and combining like terms. From there, you look for that. If there isn't any, then you go with addition and subtraction, then multiplication and division. Okay? From there, we go with isolating the variable. What does that mean? Leaving the variable by itself using inverse operations. What are inverse operations? If I say addition, what is the inverse? Subtraction. If I say multiplication, what is the inverse? Division. Okay? From there, plot your solution on the real number line. So that means we need to graph that piece. And then at the end, check your solutions by substituting into the original equation. So we got the steps. Now, an easy way to remember these, I usually tell my students to circle the very first word, the action word for each step. So check this out. First step, we're going to what? Simplify. Second step, we're going to isolate. Third step, we're going to plot. And fourth step, we're going to check. Simplify, isolate, plot, and check. Simplify, isolate, plot, 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 check. Tell your neighbor the steps, please. Okay, so it's 4 basic steps that we're going to follow. Make sure we go through each step. Okay, so here we go. Let's get started. So on your paper, I gave you the Cornell note. Let's start with the first one-step equations. We're going to get to 2 steps, okay? So let's look at these. So I'm going to do the first one, pens down, eyes up here, so like that you know exactly the way I want it done. Here it goes. Step 1, for those of us that got confused last year with equations, I want you to start by sketching a line down the equal sign. Like that, it differentiates which side we're working on. Are we there so far? Okay, by looking at it, we know that the variable is on the left side. So in order to start simplifying this, step 1, it says simplify. That means get rid of grouping symbols. Do we have any grouping symbols? No, there's no grouping symbol here or here. Are there any exponents? No. From there, we go with addition or subtraction, and at the end with multiplication and division. Who noticed that the operation's inverted?
I noticed.
You guys notice that? From the order of operations, they inverted. You guys see that? Okay. So check this out. So therefore, what's next to the x? Addition of 2. So what is the opposite of addition? Subtraction. So we're going to subtract 2 from here, subtract 2 from there. Because whatever we do to one side, we do to the other. These cancel. We bring this down. X equals 23. Michael Jordan. Hold on. I'm still not done. Check this out. Pens down, eyes up here. So let's see. Step 1, simplify. There wasn't anything. Step 2, isolate. Isolate means to leave the variable by itself. Did I leave it by itself? Yeah. Step 3, plot. That means we're going to plot on the number line. So check this out. I'm going to plot this on the number line. Use my number line right here. And I got 0. I got 1, 2, 3, dot, dot, dot. 23 is about right there. And I plot the point. Are we there? Okay. And then at the end, I'm going to check. So let's see. I rewrite my equation, x plus 2 equals 25, and instead of x, what am I going to write? 23, so this is 23 plus 2 equals 25. What is 23 plus 2? That's 25. Is 25 equal to 25? Yes, and I'm done. Okay? Copy that, please. Okay, look at this one. See if you can do this one by yourself. 12 equals y minus 8. I'll get you started with the first step. Here it goes. First step, you draw your line down the equals line. Okay, you do the rest. Go. All right, let's see. Let's see if you did what I did. Here we go. First steps first. Simplify. Are there any grouping symbols or exponents? No. From there we go with addition or subtraction. Here's the variable. Is there addition? No. Subtraction? Yes. So what is the opposite of subtraction? I add 8. Add 8. This becomes 20 equals y. Hands if you got that. Okay? From there, you do your number line. Straight just like mine. 0, 1, 2, 3, dot, dot, dot. 20. You plop it. There it is. It's a little bit crooked. There it is. All right. And then from there, you check your work. You write the equation again. 12 equals y minus 8. And instead of y, we write what? 20. And this is 12 equals 20 minus 8. 20 minus 8 is 12. Is 12 equal to 12? Yes. All right? So, with that said, let's go to this one. Let's do this one together. Line down the equal sign. Let's see. Are there any grouping symbols or exponents? No. Addition or subtraction? No. And the variable's right here. Multiplication? Yes, it's right here. The negative 2 is multiplying. Is that correct? So what is the inverse of multiplication? Division. So we divide by negative 2. Divide by negative 2, both sides. What is negative 2 divided by negative 2? That's a giant 1. What is 1 times a? A. Are these two the same sign, 14 and negative 2? No, so the answer is a negative. 14 divided by 2 is 7. Plot it on the number line. Really? Well, maybe the number line doesn't like you guys. How about that? This is 0, dot, dot, dot. We got 1, 2, 3, dot, 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 to negative 7. And guys, the reason I'm getting you guys practice with this, because we're about to move on to inequalities, and in inequalities there's a lot of graphing, so at least I want you guys to get familiar with it. Yeah. Remember, I don't do stuff just because I'm crazy. I mean, I might be a little crazy, but because I just want you guys to do work. No, I'm getting you guys ready for the next step. Okay, yes. Okay, for homework to graph. Yes, thank you. All right, let's just check. Let's check this. We write negative 2a equals 14. And instead of 8, everybody look up, please. Whenever you get these with multiplication and division, I want you to open up parentheses. Check this out. Open parentheses. All right, let's continue. So here, whenever you get to these, multiplication or division, I want you to open up a parentheses. Because if you don't, you're going to make a mistake. Some of you substitute without a parenthesis and you think you're subtracting or adding. But what's happening between the negative 2 and a? Multiplication. That's why you open up parentheses. So what goes in the parentheses? Negative 7 Negative 7, bring down the negative 2, the equal, the 14. Are these the same sign? Yes. 2 times 10, that's 14, equal to 14, and we're done. Yes, pretty good. So far, so good? All right. And let's go to the next one. Let's do this one together. Draw and line down the equal sign. Let's see. Are there any grouping symbols? Yes, but we can't simplify anymore. How about addition? No. Subtraction? No. Multiplication? No. Division? Yes. Here's being divided by 4, so we need to multiply times 4. Whatever we do to one side, we do to the other side. Now check this out. Heads down, eyes up here. Look at this. I'm going to rewrite this right here. M divided by 4 times 4. How do we multiply a fraction times a whole number? We over 1. Is that correct? M times 4 is 4m. 4 times 1 is 4. What is 4 over 4? 1. 1 times m is m. Everybody there so far? But in order to avoid doing all this work, check this out. I'll take this. Everybody look. Oh, now I'm back over here in the equation. When you see this, a fraction times a whole number, just draw me a lazy 1 like this. You guys see it? Because you guys don't see it? 4 over 4 is 1. 1 times m is m. Are these the same sign? No. This is negative 12. Copy that, please. So I said we avoid doing all this work with 2 or more steps. Does that make sense? Okay. On the back side of the page, I introduce what we call two-step equations. So check this out. Let's work these together. Very similar, but if you follow the steps that I gave you, you'll be fine. So here we go. Draw your line down the equal sign. And once again, we start with grouping symbols. Do we have any? Nope. Do we have addition or subtraction? Yes, here's my variable. They're adding 2, so we do what? Subtract 2. Whatever we do to one side, we do to the other. We're left with 3x equals 23, Michael Jordan. Next, we go with multiplication and division. Multiplication and division. So let's see. Here the 3 is multiplying, so what is the inverse? Divide by 3, divide by 3, by 3, m, m, where did I get m from? I thought it, because I was thinking Michael Jordan song. X equals 23 divided by 3, let's see, 23 divided by 3, that's 7, 7 times 3, that's 21, how many left over? 2, so this is 7, and 2/3. Let's not check this one or graph it. Let's go to the next one. How about that? Okay. Draw your line down the equal sign. Are there any grouping symbols or exponents? No. Okay. So let's start with addition and subtraction. And there's subtraction. See if we can do that one by ourselves. Go. All right. Let's see. So here you added 8 to each side. This became 22. Oh, my bad. 20. Yeah, I was testing you guys. 20 equals 4y. And then at the end, we divide by 4. Divide by 4. 5 equals y. Hands if you got that. Okay, very good. Okay, let's move on. Here goes to the next one. You have 2 more underneath, right? Okay, so let's see. Let's do this one together. Line down the equal sign. There it is. Let's see. Is there any grouping symbols? No. Addition or subtraction? Yes, right here. So I subtract 12. Subtract 12. Oh, you don't have that one? Oh, my bad. Okay. Sorry. Okay. Okay. You have this one. All right. My bad. Okay. Here we go. So line down the equal sign. Is there addition or subtraction? Yes. But be careful with this one. Check this out. Head down, eyes up here. Circle this one. This is a negative 1 times a. Is that correct? So what's next to it? A positive 8. So how can we get rid of that 8? Subtract 8. Subtract 8. So be careful with these. So copy that, please. These cancel. I bring down the negative 1a equals 6. Yeah, they're kind of tricky because it looks like a subtraction, but it's actually a -1 multiplying. Remember that? The coefficient? Okay. So here, what is the -1 doing? It's multiplying. So what is the inverse? Divide by -1. Divide by -1. A equals -6. Yep. All right. Let's look at this one. Looks kind of funky, but we'll get there. Let's see. Line down the equal sign. Grouping symbols. There is one, but since we cannot simplify the numerator denominator, I'm going to go with subtraction. So what is the inverse? Positive. We add 6 to each side. These cancel. -3 and -6, that's +3. Bring down the m divided by 4. So if the 4 is dividing, what is the inverse? We do what? Multiply. Multiply times 4. Multiply times 4. So therefore, we're left with 12 equals m. How are we doing? Yes? Yeah? Gustavo, you alright? Yeah, yeah. It's like boom, 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 boom. Alright, is it coming back, guys? Yeah? You guys did some of this last year, but now I'm starting to add like negatives here and there that they're a little bit odd places, right? So far, so good? Okay, let's see. Let's continue. Copy these two. See if you can do those two by yourself. Go. Yeah, we got 12 minus a equals 27. It's very similar to the one we just did. And then -7 equals m over 9 minus 12. All right, let's see what we got. For this one, you subtracted 12, then you're left with -1 times a equals 15. Divide by -1, divide by -1, a equals -15. Hands if you got that. Okay? Look at this one. This one we add 12, you got 5 equals m over 9. Multiply times 9, multiply times 9. So therefore 45 equals m. Hands if you got that. Okay? Alright, let's move on. So check this out. You're going to get to these. Copy this one down, please. This is the last one I'm going to give you. 2/3 times r plus 3/4 equals 7 over 12. Okay, copy that. Pens down, please, eyes up there. Who notices that we have fractions all the way? And who loves fractions? Anyway, to work this one without fractions, check this out. First of all, what would be our common denominator here? 12. So therefore, check this out. Everybody look up. Pens down, please. You multiply everything times 12. Check this out. So this times 12, that becomes what? 24 over 3r plus, what is 12 times 3? 36 over 4 equals, what is 12 times 7? 84 over 12. Are we there so far? From there we simplify. What is 24 divided by 3? 8r plus 36 divided by 4, that's 9. 84 divided by 12 is 7. You know how to solve these? Yeah, so the only step they need to worry about is multiplying times the common denominator, the entire equation. But notice that I only multiplied the numerators, yes? All right, so homework. Homework is on page 81 through 82, and we're doing numbers 1 through 33 odd. All right? Put in your homework in the back. Have a good one, guys. Enjoy your homework. See you guys tomorrow.